Alrighty, in lesson 4.3, we are going to continue solving our trigonometric equations. So in this first video, we're going to look at our half and double angles. And then in the next videos, we will use identities and simplify. And then we're going to look at a word problem. So let's go ahead and solve this equation with either a half angle or a double angle. And you'll notice that I highlighted half angle because right here is the angle, and we can see it's a half angle. So when we write our answer, we want our answers to be in degrees, and we want it to be in one rotation of our circle. So the first thing I want to do is try to get the cosine by itself. So to get cosine by itself, I'm going to divide both sides by 2, just like I would with any other equation. So I'm going to get the cosine of x over 2, or half x, equals 1/2. Now if we use our angle identities, our half angle identities, we know that the cosine of half a equals plus or minus the square root of 1 plus cosine a over 2. So what I'm going to do is I'm going to take out this cosine of half x and I'm going to put in the half angle identity. So let's take out the cosine half x. Let's do the square plus or minus the square root of 1 plus cosine x over 2, and that will equal 1/2. So that is going to give us two equations. We are going to get a positive 1 plus cosine x over 2. That equals 1/2. And then we also get negative square root of 1 plus cosine x all over 2 equals 1/2. We're going to see here pretty quickly that this was extraneous. I really didn't need to do this, but I wanted to really focus on what is the algebra saying. Oops, let's remember this is over the entire thing. Alrighty, let's get rid of that square root because we've got to get the cosine x by itself. To get rid of the square root, I am going to square both sides. So if I square the left side, I get 1 plus cosine x over 2. 1/2 squared is 1/4. I'm going to do the same thing here. Got to get rid of that square root. So when I square root this, don't forget I'm going to square root that negative, which turns it into a positive, which still gives me 1 plus cosine x over 2, and that will again equal 1/4. So I get the same answer regardless, but I still like to break it down what it is. So I'm only going to solve one of these because it's the same equation. I need to get cosine x by itself. That's always been the goal. Let's multiply both sides by 2. So 1 plus cosine x, 1/4 times 2. So I'm going to multiply this side by 2. Actually, I'm multiplying both sides by 2. So here my 2's are going to cross out. And then 1/4 times 2 gives me 1/2. Let's subtract 1 from both sides. So cosine x, 1/2 minus 2/2 is negative 1/2. So let's use our inverse functions to figure out what x is. So arc cosine, or the inverse of cosine of negative 1/2, that's going to equal x. So what we want to find is on the unit circle, where are my cosine values negative 1/2? Well, the ones closest to my angles, the pi over 3 reference angles. So we're looking at the reference angles that are pi over 3, because this is the point negative 1/2 radical 3 over 2. And this is negative 1/2 negative radical 3 over 2. So where is x? Oh, I'm sorry, I don't want it in radians, I want it in degrees. Oh my gosh, I remember what the problem says. So that's not pi over 3, it's 60. My bad. So we know x is going to happen at 60 degrees less than 180. That's 120 degrees. And it's going to happen 60 degrees more than 180, which is 240. So my solution set is 120 degrees and 240 degrees. Boom. Not so bad. Let's do another half angle, this time with sine. So when this time we want to write our answers in radians, it can be 0, it can't be 2 pi. So if you end up on the positive x-axis, we're going to say 0, not 2 pi. Excuse me. So I've got this equation. Let's get the sine function by itself. I'm going to add radical 2 to both sides. So 2 sine of half x equals radical 2. I added radical 2 to both sides. Now I'm going to get rid of the 2 in front by dividing both sides by 2. Okay, so we want to find this half angle. Well, the sine of a half angle is going to be plus or minus the square root of 1 minus cosine x all over 2. So that's what the sine of 2a equals. So I'm going to plug that in for this. So we're going to say plus or minus the square root of 1 minus cosine x, because we're taking half of x, all over 2, and that's going to equal radical 2 over 2. So we're going to square both sides to get rid of this radical. So 1 minus cosine x over 2 equals 2 over 4. Now, 2 over 4 is really 1/2. So I'm going to go ahead and I'm going to reduce that down. Because I squared it. Radical 2 times radical 2 is just 2. 2 times 2 is 4. Simplifies to 1/2. Let's multiply both sides by 2. If I do 2 times 1/2, we're going to end up with 1. So I'm going to subtract 1 from both sides, and I get negative cosine x equals 0. Cosine x equals 0. Okay, so where does... So let's take the inverse. Sorry, I got distracted by the bright, shiny objects in this room. So what this is asking, what angle in radians produces a cosine value of 0? Well, that happens here and here. We happen at 0, 1, and it happens at 0, -1. And this is 90 degrees, and this is 270 degrees. So my solution set is, oh, gosh darn it, I just said don't do degrees, do radians. Please pay attention to your markings. And then, so what we notice is up here at 90, that's pi over 2, and this is 3 pi over 2. Pay attention. Goodness. Let's make sure we get our answers in the format that is being asked for. So that's my answer set. Now you can always double check your answer by I am saying x is pi over 2 and x is 3 pi over 2. You can plug those values in using your calculator. You can say 2 times the sine of, and then I would use parentheses, pi over 2 divided by 2, because we're going to take half of it, because that was one of my answers. That was my first answer. And then we're going to subtract radical 2. And if you put all of that in your calculator and pi over 2 is an answer, you better get 0. So you can always double check using your calculator. Alrighty, so that takes us through example 1, parts A and B. So if you have any questions, please come in to class ready to ask, and we'll definitely hit these up again. Have a great one, everybody, and I'll see you when I see you.